are going to solve equations containing decimals and fractions.
Today we're going to solve equations containing decimals and fractions.
Hoy vamos a aprender cómo resolver ecuaciones con decimales y fracciones.
Alright, our first example is an equation x plus 5.7 equals 2.5. As the people before told you, we're going to solve equations containing decimals and fractions. Okay, so you got to take your past knowledge on equations and put it with your present knowledge of decimals and fractions. Now, remember in equations you do the opposite. So here I have x plus 5.7 equals 2.5. There are two things on this side of the equation and one thing on this side. So we have to deal with the left side. You always go to the side with the most and try to reduce the amount. Okay? Now the opposite of addition is
Subtraction.
so we're going to subtract 5.7 on each side. That's how we're going to say it. Subtract 5.7 on each side. Now when we do that, 5.7 minus 5.7 is 0, which is good. So that leaves us x equals 2.5 minus 5.7. Now look guys, when you were kids, you could do 5 minus 2 was 3, right? But could you do 2 minus 5?
No.
No. So when you have a problem like that, 2 minus 5, the answer is going to be what?
Negative 3.
Negative 3. So right here, I have 2.5 minus 5.7. My answer is going to be negative 3.2. So that's your answer. You just solve the equation by doing the opposite. Alright, here's our first example with fractions, fracciones. Okay? Now, what do we do to solve this equation y minus 1/4 equals 2/3? Brian?
You add 1/4.
Yeah, that's right. You add 1/4 on each side. Okay, now, tell me what negative 1/4 plus 1/4 is. 0. So that leaves me y equals, now I've got to find what 2/3 plus 1/4 is. So I'm going to rewrite 1/4 plus 2/3 over here. And I have to get a common denominator. What will my common denominator be?
12.
That's right. I'm going to multiply 4 times 3, and I'm going to multiply 3 times 4. And so what I do to the bottom, I have to also do to the top. Okay? So 1 times 3 is 3, plus 2 times 4 is 8, over 12. What's 3 plus 8? 11 over 12. 8, 9, 10, 11. So my answer is 11 over 12. Y equals 11 over 12. Now, will that reduce?
No.
No. Alright, here's another example. On this example, don't get fooled by the plus sign being over here. You have to look at the 2.7 in the end and say, which do I move over there? The 2.7. Now, the way I move the 2.7 is to do the opposite. The opposite of a positive 2.7 is a negative 2.7 on each side. So we're subtracting 2.7 on each side. So what is 2.7 minus 2.7? 0. So I'm going to have n equals something. 8 minus 7 is 1. 5 minus 2 is 3. So my answer is n equals
3.1.
3.1. Alright, here's another example. This example contains fractions. Alright, in order for me to solve this, I have z minus 2/5 equals 7 over 20. Okay, I got to do the opposite of minus. So I'm going to add 2/5 on each side. So really, they're not testing what you know other than they're saying, do you know how to add fractions? Now, in this fraction, is there anything I can multiply 5 by to get 20?
Yes.
What?
4.
4. Now, since I multiplied the bottom by 4, I have to multiply the top by 4. So I'm going to have 7 plus, now 2 times 4 is 8, over what? 20. 8 plus 7 is 15 over 20. Now, is that my answer?
No.
No, because I have not reduced. Okay, so let's make sure that when you reduce, you write 15 over 20, and then you do your prime factorization of each. The prime factorization of 15 is 3 times 5, and the prime factorization of 20 is 2 times 10 which is 2 times 5. Now I can cancel out these two 5s, so I have 3 over 4. So this reduces to 3 over 4. Alright, our last example is a little more tricky. We learned that if you have a variable and then 2 negatives in a row. Now this is a minus and a negative. That's just like having 2 negatives in a row. What do you do with the 2 negatives? Yeah, you leave this alone, you change this to a plus, and you get the opposite of negative 1/9, which is positive 1/9. The reason we did leave change opposite was because we had a minus sign. Now, what do we do to go about solving this equation?
Subtract 1/9.
That's right, we're going to do the opposite of positive 1/9, and we are going to subtract 1/9 on each side. Okay? Now, this goes away, and J is going to equal whatever 1/6 minus 1/9 is. So let's solve 1/6 minus 1/9. That's 1 over 6 minus 1 over 9. Now, what do we have to do what do we multiply what by?
Multiply 9.
Now, hold on, you
Yeah,
can't
you have to come in
multiply,
denominator.
hold on, you can't multiply 6 times anything to get 9, and you can't multiply 9 times anything to get 6. So we're going to multiply by each other. 6 times 9 equals 54, and 9 times 6 equals 54. Now, what goes on top? What's 1 times 9? 9. And what's 1 times 6? 6. So now I have 9 minus 6, which equals 3 over 54. Okay? Now I got to do my prime factorization of 3 over 54. So I'm going to do 3 is 1 times 3, and 54 is 2 times 27, which is 3 times 9, which is 3 times 3. So what do we have that'll cancel?
3 and 3.
This 3 and this 3. Now on top that leaves us a 1 over, what is 2 times 3 times 3? 3 times 3 is 9, and 2 times 9 equals 18. So we reduced 3 over 54 to 1 over 18. But now that's not our answer. Okay, we have to include the variables. So we have to say J equals 1 over 18. And that is your final answer.
Today we learned how to solve equations using decimals and fractions.
Today we learned how to solve equations containing decimals and fractions.
Hoy aprendimos a resolver ecuaciones con decimales y fracciones.